relational database commit without two-phase commit, so that's not new. And the concept of crypto, that's been around for quite a while, because you can't log on to, and you don't go anywhere. HTTPS is all crypto. You know, people don't know that, but it's all crypto. It's all handshaking. It's all that technology. But this thing, you know, that came out of Satoshi and the Bitcoin, and what they created, and what they added was the magic sauce was this what they call proof of work. And the proof of work was simply, it's a lottery. Okay, it's a lottery system. It's a poker game. Okay, that's all it is. But it's implemented in a manner that you can't defeat the lottery. You can't. Well, you can. I won't go into that. But and quite frankly, I'll tell you right now, Bitcoin's broken. Forget about it. It ain't going to happen. I can show you some charts, right? And they show you, and that's part of what we're going to talk about a little bit about tonight, about the whole mining pool thing. Okay, when you look at the charts, okay, I won't pull them up, but when you look at the charts, it's real simple. And I'll go from the worst. Okay, so you have basically a pie, right? But the point is, these are the miners. Miner 1, miner 2, miner 3. 51% you own the network. So, I mean, there's opportunity there to collude. And the miners are so big enough that it just takes one right moment that they get together and they say, hey, look, we know this is going to come down, but we better get out quick and let's make our exit. All right? And they will. When you look at the derivatives, when you look at Ethereum, Ethereum is not much farther from that problem, because they're using what they call proof of work. Ethereum uses proof of work. Ethereum tried to create an algorithm to mitigate some of this activity, but it's a human element, and they can't mitigate that. So we have the newest kid on the block called proof of stake. Okay? And proof of stake came out, and proof of stake is basically, it's where we all get in a room like this, and we all, so we don't cheat, we all have to put money in the pot. And the idea is, if you got enough money in the pot, your incentive is not to cheat. Okay? But if you ain't got no money in the pot, and you ain't got nothing on the line, hey, and there's an opportunity for you to cheat, and you and I can get together and we can take the pot, well, we might think about it, right? Okay, so that's, blockchain is a game, right? Life is a game. Our financial system, right, is always is broken too, but it's risk mitigated, right? So if you lose your money, you can make a phone call, right, and you get mitigated. Depending upon the circumstances, you'll get all your money back or most of it back, right? So that's life. So these systems that are telling you trustless systems and all that, no, and, to a degree, yes, but reality, no. But we will get there. We will get there, but it's an incremental fashion. Now we're at what we call delegated proof of stake, because with proof of stake, it's the same old thing. It's basically there. The problem is whoever has the most money gets to be the miner, right? So it's like, wait a minute, isn't that what life is already like? It's like whoever has the gold makes the rules. So that's not fair, right? That's not going to work, right? Because the little guy don't get no vote. Okay? That's what's so beautiful. That's why we have this country the way it is because the fathers, the geniuses that created our Constitution, our governance, right? Which blockchains have governance, they need governance. Ethereum is struggling right now to try to get governance, right? But others already saw it, like EOS has governance, and EOS is working, okay? So, but what we have, what makes us work, is this thing called the Electoral College, right? Because that way you can't get, you don't get the masses overruling the republic, okay? So it's the same way, like little miners, big miners. Okay, but we're all citizens of the country. But just because I live out on a farm and I'm sparse, what? I don't have any say for the rules. So the Electoral College is like a weight, right, to the votes. And it's worked so far. If you get rid of it, we're gone. We're gone. We're dead. okay? Because then the mob will rule. Whoever has the most money, pump out the media, brainwash enough people, give away enough goodies, and you're in forever. And once you get in and you got control, you can open up borders, you can bring all the folks in you want, and for the rest of eternity, they're going to vote for you, and that's it, okay? So that's what blockchain's struggling with too. Same thing. So delegated proof of stake says, oh, okay, well, we're going to delegate it. Okay? It's just a finer line. All right, and there's papers on it that you can read. But that's where we're at, delegated proof of stake, EOS. Okay. What's holding them back? UX, right, is the main culprit. And UX is two things. One, the friction of getting on and off, and the experience. Okay? It's terrible. It's terrible. And the only ones that use it are the ones that are really enthralled and enthusiastic to do this. But from a mass point of view, you know, mom, dad, the kids, everybody out there, no, right? They don't want it. They want the convenience of the credit card, right? Everybody wants friction-free. And make it easy and make it fun. That's the secret, and that's where we're at. And those who cannot deliver on that second half of the equation are gone, okay? So that's what you got to look at. So tonight, why is it EOS? Well, first of all, WebAssembly, we're going to talk about that. This is major, okay? This is what got me started on this tangent here. So back in 2015, I saw blockchain in the enterprise. About a year ago, probably maybe a year ago or so, maybe a little longer, but I've been watching WebAssembly. And in my meetups, I've been mentioning it to people that it's coming. First with, I would tell them, it's a W3C International Standards Body. Well, right there tells you something, okay, because they set all the web standards, right? Like HTML, HTTPS, POP3, you name it. Anything that's with the web, W3C sets the standard. So, you know, you got to look there. But it's a maturity curve, right? And that's where they're at. They've been doing this for a few years. They're building out the standards. 2017 was a major break because all the vendors that make browsers got on board. That's critical, okay? And they built it in to the browsers. And we're only at the very beginning of this thing. So you guys are lucky because you have opportunity to try to capitalize on this because others aren't here. It's right like that. And it's going to come and it's going to be like, they're going to be catching up. Okay? And this has far more implications than just the blockchain that we're talking about. This is going to revolutionize, this is changing the entire web, period. It's changing web applications, period. Okay, Sawtooth. So EOS is the permissionless guys, right? They're the public chain that's taking they're really rocketing right now. Okay? And when I measure that and I say that, I'm talking about in the concept of dApps, right? dApps, distributed, decentralized applications. Because without the dApps, at the end of the day, what's the blockchain good for if there's no applications? So for the last for the last 4 years, everybody's been just focused on the hardcore R&D and technology of the foundation, okay? And the whole dApp thing is like, yeah, but, right, it's not there. Not a lot of focus on it because everything's been on the foundation. But WebAssembly was being created not out of blockchain, but what we're going to see from other movements. But it's all, so what we're getting today is this, help me out, what's the word? Convergence. Convergence, right? So we have the convergence of these international standards. We have a few blockchain entities that see this, right? Have seen it and are working on it, both in the permissioned and the permissionless space. Okay, so it's not one of those, you know, Bitcoin versus, you know, the company blockchain. You know, it's not one of those type of arguments, right? This is universal. So this is why I picked EOS, because EOS represents right now the wonder kid in blockchain. I mean, literally, I do believe they're going to eat Ethereum's lunch. It might not be them. There might be a derivative. Hopefully it'll be me, because I've got my own consensus that's derived out of that, that I hope I can get patented. And if I get it patented, combined with some technology that I've been working on for the last 4 years, it will totally revolutionize and literally overnight kill every one of these guys. Sawtooth, this is the permission. Okay, this is out of Intel. It's got legs. It's in competition, obviously, with IBM's Fabric. You know, it's up there, and they're very aggressive on their evolution. And they were one of the first ones to sort of make that extension over to the other side by saying, hey, what Burrow is another group in here in Hyperledger that came out of the permissionless world that had an EVM, right? The Ethereum virtual machine. So if you know what Java is, Java has its virtual machine, and you write code, but it ends up running as in the virtual machine, right? Which makes, you know, if you got a virtual machine, you can run it anywhere, right? That a virtual machine will run. That's the whole idea. Write it once, run it everywhere. That's what made Java, right? All right. So we're getting to that same kind of mindset. Okay, so Burrow brought over into this group the EVM, because they had their own, they wrote a version, right? But they were able to open source, and they were able to give it the proper licensing. Okay? So that meant that inside Hyperledger, they had the technology which was the heart and soul of Ethereum, the virtual machine, because that's what runs the smart contracts. So they saw that from day one, and they had Burrow build them an EVM without the cryptocurrency. Okay? Cryptocurrency inside that group was a no-no. It was like, shh, we don't talk about cryptocurrency. Baggage. Bad news. No. But that's changing too. Okay? Because people are realizing that it's, you know, it's like the internet. It's like, did porn stop us from using the internet? No. But if you were one of the early people on the internet, people would look at you, right? What are you doing on the internet? Right? All right, so this is important because this represents the enterprise. This is important because this represents the world and what's new about the world. And this is the missing piece, UX, that will make this stuff finally happen. But unfortunately, when that does happen, all this stuff will sort of disappear, in the sense that it's behind the curtain. It's down in the basement. It's out back. Okay? It'll be the plumbing, the transmission. Nobody will care until it breaks. Right? It's that shiny new car. It's that beautiful kitchen. Right? That's the UX. And that's the final phase of this evolution. Okay, let's get started. So the first thing we're going to talk about, we're going to go over WebAssembly. All right. And if at any time you have questions, just comments, you know, go ahead. Okay.
So Marcus, WebAssembly, the UX.
WebAssembly, what is it?
Is that it's going to build the UX, or is that something that's going to allow the, in essence, APIs to?
It's going to enable the UX.
Okay.
Yeah. Okay. So what is WebAssembly? Right? The history of WebAssembly. So JavaScript, Brendan, Ike, in 10 days, wrote JavaScript. It was a toy. It was just a toy. In fact, I think he said he was writing it initially for, I don't remember. But 10 days, it was a toy that he put together in 1995. Okay, well, hey, you know this? You know what? You know what? His latest. You know what he's done lately? Anybody know what he's done lately?
That? A basic attention token?
And
I don't know.
Brave,
Oh, Brave, yeah, the browser.
which is what supports, which is what's
Brave,
behind,
oh, yeah.
which is what behind that. So he created Brave, the new browser. Okay, anybody know what Brave really is?
It's Firefox.
Blockchain browser, right?
It's Chromium. Chromium. Chromium is Google Chrome. It's the heart. It's the engine inside. It's the HTML engine inside Google Chrome, their browser. But it's open. They open sourced it a while back. Okay. So he took that and built Brave, and of course he tokenized it with the BAT tokens. And the concept is, okay, well, we're going to get rid of the ad. We're going to make advertising a lot less invasive and more profitable for you. But my personal take is, because I've been in it, it's not. I don't find it the UX, the experience, because now it's being replaced with this constant prompt to tip. Tip me. Every time you get a content, you want to tip. And they're doing some nefarious things like sending headers to Coinbase. You know, it's like whatever. So, 2008, JavaScript, JIT, major upgrade. That's just-in-time compilation. What'd you get out of it? A 10x performance. So you got the web as it is today. So you can do things at 30, 40, 60 frames a second. There's really nothing you can't write if you know how to do it. Fast forward. When that happened, Node came about. This gentleman here, Ryan Dolph, took a piece of code called V8, which runs Node, and what that is a JavaScript engine. And I remember when it came out, I was so hot on it because for me the idea was that, oh wow, you mean I can write and I can now run JavaScript outside the browser? I could actually create a real application, a desktop application. This is interesting. I could put this into a server, an enterprise application, right? And I can write JavaScript and run JavaScript. So this is really cool. Okay, but he created Node, and Node took off. Then out of that, people started writing code for Node called modules. Okay? And today, there's over 900,000 modules in NPM. Anything you can think of to do as a programmer is there. So, but it's JavaScript. Okay? And it's like, so when I'm writing code and I'm in that JavaScript world, it's like, I'm not going to write it because I know there's somebody already who wrote it. But there's issues here too, okay? There's no panacea. There's no free lunch. But the point is that you need to understand is the momentum, right? And nothing in the world comes close to this. So nothing's going to replace it. Because no one's going to rewrite all that. JavaScript, it hasn't stopped. Okay, it has an international body, right? And they've been cranking this stuff out. Look, 9th edition now. Okay, 2018. All right. So it's like everybody right now is pretty much writing what they call ES6 or ES7, which is modern JavaScript. So they keep updating the language, right, and giving new features. So the language is still moving forward. In the meantime, there's only one way to write a web application. If you got to do JavaScript, you might hate it, but you've got to do it. You know, there's no way around it. Right? People tried, but they failed. So what we get today are these things called transpilers. Okay? And there's pretty much a transpiler for every language you can think of. What does it do? Well, like this Python. A lot of people write Python, but you want to turn it in. There's over, about 15 different tools for transpiling. What does that do? It takes your Python and turns it into JavaScript so that you can go run it as a module in Node on the browser. So, during this time, Google and Mozilla have been hard at work. So they went 2 different paths to end up here where we're at today. Google started with this concept of a native client. Okay? And this is what their little model looked like. It was a portable native client, obviously portability, running anywhere, portable executables, right? It's binary, fast, small, right? The native client architecture, specific IXE, a tool called Pepper, which is an open source API for creating these native modules, native client modules, and this was their tool chain. So you start with like C, C++, and you go down the tool chain, right? So on this side here, you're in the compile time, and then on this side, you're in the runtime. So over here on the portability side, you get this translator, and then you finally get your web application, and over here, you have a web store application or via a browser plugin. So, like, what does that mean? Well, obviously, this is like narrow, right? Because this means very restrictive platforms. I mean, you have to basically go to bed with Google if you're going to implement this. And who's going to be in charge? Google. So your destiny in this space is going to be whatever Google does, right? And obviously you can see that a lot of people didn't want to go this way. And here's what it would look like. So Pepper's role was in the native client application, right? This is what Pepper would do for you. You take your HTML, you create a manifest, your JavaScript, and then Pepper, that whole tool set, would then create this guy here that you could then run on a platform. Okay? But like I said, a lot of detractors saw this black box, nature of the applications, potential security risk, complexity, blah, 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 blah. Now, Mozilla, they went another route. Right? So Mozilla, they're the people behind Firefox. Okay? And they are really friendly to us. Okay? Because they don't sell ads. Well, they might sell ads, but they're not a search engine. Right? So they're not into making money with your privacy, per se. They might, but not big, they're not Google, right? So their incentive, though, is different. Right? They just want to build the best browser in the world, right? And the best technology. And they hire people that have an attitude of open source and that want to deliver great things for people, right? Instead of a capitalistic mindset of let's build something really cool we can really make a lot of money with. No, let's build something really cool that people can use, right? So they're sort of right now, I see them, they're really the white horse for us from a technology standpoint. You can get rid of everybody else. As long as you got these guys around, we're still rocking and rolling. So what do? They went this route with this thing called ASM.js. It's short for assembler JavaScript. It debuted in 2013 and provided a way for developers to translate their C and C++ code to JavaScript. Okay, they implemented a strict subset of JavaScript, right? And it has to be amenable to what they call ahead-of-time compilation. This is critical, ahead-of-time compilation optimization. So that they can look out, compile, and then run. Not bring it down to me, let me look at it, let me compile it, and then let me run it. It's like, no, you're looking ahead, and then, so it's running, and it's looking ahead and compiling. So when it gets ready to run, give me the next instruction, it's ready to go. So it's very critical. But you cannot do that with every language, right? There's issues involved there when you want to do that. they're using a tool. This has been around for a while. This was one of these tools that started out as a transpiler and then became a full-on tool set called Unscriptum, that you can take C++ code and it can be transpiled down to this ASM JavaScript. And then you can run it in your browser. So this is what their tool looks like, their chain. This forms, and this actually will form what was called by W3C when they look at this is the minimum viable product. You all know what that means. Right? Minimum viable product. Right? And this is what their focus was out of the gate. So, which is good for us because instead of sitting around and trying to make a gold-plated product, which probably would never happen, which means we'd never get anything, they said, no, let's take the other attitude. Minimum viable product, and let's get it going, and then get people involved and let it grow organically from there, based upon a core set of specs and principles, right? Which is what they've done. So the official WebAssembly site mentions this, right? In their section entitled WebAssembly High-Level Goals. It's an ASM module, is a text file, but it's not really a text file you might think, okay? Because it's sort of cryptic looking. That has to be transferred over the network before any compilation can take place. That's important. Think about that. Has to be transferred over the wire before you can compile it. A WebAssembly module is in a binary format. Now we have WebAssembly. Basically, the two camps came together. And obviously, under the umbrella here of W3C, the Worldwide Web Consortium, and they formed the WebAssembly Working Group in April 2015. And by 2017, they had something out. WebAssembly's binary format, the .wasm file, corresponding to the WASM file, combines the facets of the ASM Mozilla output with the portable native client concept of a distributive executable. So that's important because they both contributed. They gave us this, no, you got to run executable. It's got to be an executable when you get there. It's got to, it's got to boom, ready to go. Whereas these guys weren't like, no, we're going to send you all that JavaScript, we'll compile it over there and then run it. So, how will it succeed? Many have tried to capture this new evolution and try to get out of this JavaScript, try to give somebody something new. Right? Because let's face it, the web right now is limited by JavaScript. You can't do anything in the web unless JavaScript can do it for you. We have a canvas. Oh yeah, okay, canvas, so we can do nice graphics now, but it's still JavaScript. So how will it succeed? First, it's important that we know that it's a collaborative effort. No single company goes alone. Oh, wow. Think about that. And think about all of the groups out there trying to go alone. At the moment, the following projects are involved, right? There's Firefox, Chromium, Edge, that's Microsoft, and WebKit, that's Apple. So all the major players are there that you need. Second is the interoperability at the web platform, and the JavaScript is excellent. Yes, because remember, we got we have a library of 900,000 modules that do anything and everything that you can even think about doing. Whether it's crypto, graphics, data structures, I mean, you name it. I mean, things you would never think of. Using WebAssembly code from JavaScript would be as simple as importing a module. So, they get it. It's got to be simple. Simple. Using WebAssembly code from JavaScript would be as simple as importing a module. Third, it's not about replacing JavaScript, which is good because this way it's not an adversarial environment. Okay? Because there's a lot of money invested in JavaScript. There's a lot of incumbent power wrapped up to make sure JavaScript keeps rocking and rolling. So you don't want to create an adversarial. But it's about adding new features. Well, if you add new features, then that's just going to enhance all these guys too. And it greatly reduces the amount of work to implement WebAssembly and should help with getting support of the web development community. That's us. Because if it's hard to use and it's narrow in scope, you're only going to get a very few people to use it. Okay. What exactly is WebAssembly and where can I use it? Well, WASM, that's its acronym. Same thing, right? Interchangeable. Talking WebAssembly, WASM is the same thing, it's no different, except that WASM is, might be referred to the binary file. Okay? It is a binary instruction format for a stack-based virtual machine. Okay, that's a very special kind of virtual machine. It's a very special kind of computer. The stack. WASM is designed as a portable target for compilation of high-level languages like C, C++, and Rust. Remember Rust. Okay? This is important too. Because right now, a lot of momentum is behind Rust. And also Rust also came out of Mozilla. But Rust was written ground up, like C, C++, but written ground up for today. It's a new language for today that Mozilla wrote for the web, right? But as a language, like Go. Google wrote Go because Google needed a robust language for the cloud, for the servers, for network computing, for writing modern web, not web. I shouldn't say using web. Writing modern internet applications that live out there that you never see. Okay? Because Go is not about front ends and UI, right? Go is about moving petabytes and concurrent threads running concurrently, right? Getting a lot of stuff done. Okay? The older languages that existed, Java, multi-threaded and all that, in its day it worked fine. But Go was written ground up, and one of the main guys that wrote Go was also the guy that wrote C, co-authored C. Okay? So they wrote Rust, and Mozilla wrote Rust. And my point is also that in Hyperledger, so you see a lot of server-side software being written today. If it ain't in Go, it's in Rust. Enabling deployment on the web for client-server applications. And Sawtooth that we looked at started out as Python, and now it's all going Rust. So they're set up good for this play. WebAssembly, the binary instruction format, encompasses several elements. There's a binary format and there's a text format. Okay? These are documented in the core specification, the corresponding APIs. There's two, JavaScript and web. Right? And they are separate. Okay? And they're not commingled. They're not dependent. Okay? Well, I shouldn't say that. The web is dependent on JavaScript, but it's not the other way around. Okay? And a compilation target. And there's a reason for that, because WebAssembly is not just going to be about the web. You can take it outside of the browser now, and you can run it on a desktop. You can run it on a server. You can run it on an IoT. Put it inside a smart light, a smart switch. Put a smart contract on that switch box over there. And if you haven't paid your electric bill, well, it won't turn on. It'll whatever. You get the point. Portable target for compilation can be executed efficiently on a variety of operating systems. Variety. Linux, Mac, Windows. Right? I mean, those are the main three. It's not tied to a specific environment, such as the web or the desktop. It's not tied to that. The working group did define what I said, a web API. The MVP focuses on 2 languages out of the gate because they couldn't handle all the languages, right? They focused on these 2. And there's a reason. But Rust can also be used because Rust is a lot like C++ under the covers, structurally. Compilation will be achieved through the use of CLang, LLVM backend. This right now is pretty much a universal standard. If you're dealing in compilers, a lot of Node modules that come down have some of the more sophisticated modules have a binary component to it. Okay? And the only way you can run that is it has to compile on your platform. That's how it works today. And if it doesn't compile for some reason, then you won't be able to run it. So that's a pain, right? This will get it ripped. But this is the tool set. So the point is that this is not new. Right? So this is, again, one of these comfort feelings. Like, oh, yeah, I know CLang. Oh, great. Awesome. And this is not just specific to these languages. Okay? This was created as a sort of a compiler's compiler tool set. And support for other languages and compilers. And people are building them now. The language concepts, I'll go through these quick. I don't want to get too deep in the weeds here. But just to give you an idea of what we're looking at here. From the language concepts, it's structured around these concepts of values, instructions, traps, functions, tables, linear memory, modules, and the embedder. So the embedder is that piece that's going to sit, in the browser. So if you're a browser vendor, you want an embedder. If you're an IoT manufacturer and you're selling whatever it is, like maybe, I was just reading an article. Who is it? Just doing a blockchain refrigerator, right? Blockchain refrigerator. And I know that our friends down in San Antonio, USAA, they're hot on blockchain. They're looking also at, as well as with the thermostat. Oh, I can't think of who they are. But basically, water heaters. Putting an IoT device on your water heater that's tied into a blockchain. So it's like when the water heater starts to fail, I think it's a water heater. When it starts to fail, right, it's a smart contract and it can notify. Now, I always ask myself, so why do you need a blockchain for that? And I still don't know the answer to that one. And I'm going to go down that path. It's the whole, hammer everywhere, right? But whatever. But I know there's a legitimate reason. I just can't think of it off the top. Anyway, so now here's our modules. These are the binary files that we create, okay, at the end of the day that we're going to run. Linear memory. This is what's different because this is a critical part of the design in how it controls the memory. So it's not like memory in computers today where it's all random and maybe blocked out and there's a lot of tricks and stuff. But this is effectively an array of bytes that's virtual, that has a virtual layer on it that the modules look as memory. And tables are like databases. Okay? They're like name value databases, but they're indexed too. And these are concepts that are boiled down here to the binary layer. But when you're up at your own language, right, you're not thinking about those things necessarily. For instance, when you're in C and you may want to create a table, you just create a struct. Name, address, phone number, right? And then that's going to get translated eventually into a table. Then you have functions. Right? Those are pretty self-explanatory. That's functions that you call that execute things. That's what makes up these modules, right? As well as the memory and the tables. Traps, right? Traps are like when errors happen. Try this, error, uh-oh, catch it, uh-oh, error, trap it, report it, try it again, whatever, right? Instructions, The instructions are executed within that stack machine. And that's unique because the instructions are literally like strings, right? But they're not instructions that a typical CS computer science person would expect to see. Because one, the stack is a little bit different. I mean, it's a stack. You pop, you push, it's a stack. But it's different in the sense of how it operates, right? Compared to the way the stack works in a computer. It's much different. Okay, so the languages and their concepts from a visual point of view. So we have a module over here. So we have function, values going in, values coming out, functions, values going in, linear memory to operate with for storing things, and calculating values out. And then there's table, right? In this particular instance here, this, not to be confused with what we were looking at, but this table is really cool because it has references, and these references can point to functions. So you can have a table with, 1,000, a couple thousand, 2,000 functions. In the old days, when I was in, programming in Microsoft, C, it was called a virtual, I used to use what we call a virtual table. And a lot of hackers like virtual tables because they're pointers. You can go in there and find things and do things that, I go in there and mess with the virtual table. You think you're calling your print function, but you're really calling my function, which is capturing your print and sending it to me. And then calling your print to print. And you won't even know that I just saw your account number and your password or whatever. You get the idea. So, and then that's going to become a binary of instructions, error traps. And then eventually this is going to feed down into our host environment, right, through that embedder. So this could be a desktop. Most likely today, initially out of the gate, it's going to be a browser. But tomorrow it could be the refrigerators, the cars, wherever. Wherever there's a computing device, that's going to go. And why not? Why wouldn't it? The semantic phases that it goes through. So you have a decoding of the binary format, and you can control that by decoding. So what's important to understand is that that core spec does not limit any engineer from creating anything above that binary spec. But as long as you can conform to the core spec, right, for that stack, you're good. So that means that new languages that are created will work with this. Right? Validation. Okay. So it goes through a validation, then there's two parts to the execution. There's an instantiation piece, and then there's the invocation. So what does that look like? So phase one, decode, the binary format, the module representation. Phase two, we have validation, right? With valid types, it's safe, they're well formed. Then we get our instantiation, we have our imports. Okay? So that's really cool is that you can write code that now merges other languages. So I can take, for instance, somebody writes an algorithm for sorting in Rust, and it's the fastest one out there. Someone else has written a crypto library in C that we want to use. Okay? So today, what do we have to do? Well, typically we look at porting, right? So, but tomorrow it's a no-brainer because it doesn't matter. It's like, do you know C? No, but it doesn't matter because all we got to do is just compile it down. So we can mix these languages. So you can combine multiple languages to run together in your application. It's unheard of. Never been able to do anything like that. And you get to call, and then when they get to here, they're all the same. It looks to this, it's all one. It's just a global import. And then the module representation normalizes everything. So I don't know where you came. I don't know you came from Haskell, from Python, from Go, from C, you know, whatever. Rust, doesn't matter at this stage. And then the module instance. So here's your instructions like add, calc, start. And then invocation phase 2 in the host environment. Call add, module instance. Add. Will it replace JavaScript? The goal is not to replace JavaScript, but to complement it. Remember what we said, 900,000 packages and growing. And every one of those packages can get compiled down. Where can I use it? Well, obviously, image, video editing, games, music applications, streaming, caching, image recognition, live video augmentation, VR, augmented reality. And that's just a tip. That's a drop. It's most obvious. Okay? And WebAssembly is not just limited to the browser. Remember that. What languages are supported? All right, well, C, C++, and Rust are very popular and support what's that manual memory allocation. So that's sort of the gotcha. That manual memory allocation. What does that mean? Well, that means that you go allocate your own memory. And when you're done with it, you got to go deallocate it. So for an old school like me, that's taking me back to the horror war, you know, to the horror days. All right? But in today's world, from like a Java point of view, in modern languages, you don't worry about, you don't do that. You don't have to go and, okay, well, how many bytes do I need to allocate? Okay, well, how many references do I have on that byte, on those bytes? Are they all cleaned up? Can I now get rid of it? Oh, you know. No, that's all gone. But the point is that the modern day languages do all that memory management, Java per se. Okay, Java is the classic, all right? So Java is beautiful because it took away that pain point and lets you just focus on the solution and not worry about all that work. But now, it doesn't work too well because there's a thing called garbage collection. And you don't really have a lot of control over garbage collection. And you do need a lot of control here, in this environment, because it's, as you can see, it's not a free-for-all where you just load it up and go. It's very constrained. Okay? Very controlled, very constrained. And the only way that they can make it work is with this manual memory. It's not that you have to do it. It's just that the language can't have those nuances where it wants to go and do it for you. Okay? So don't let it scare you in the sense that, oh my God, it's going to be a nightmare. No, it's just the underlying architecture for the languages that are out of the gate. Now, eventually, they'll tame the garbage collection languages, right? Because I could write Java and turn off garbage collection. If I write good Java, right? I don't need garbage collection. In fact, most of the time we end up trying to mitigate. You don't know how many jobs I've had trying to tune that stuff. And most of the time it's just a battle of trying to like turn it off or, you know, turn it down. And then balance that out. And then find the bad code that proliferates the memory that causes these moments where the code freezes because the garbage collector kicks in and says, oh, I got to go clean up all this stuff or we ain't going to have no memory. Okay? And there's been a whole decade or more, $1 million businesses been built successfully just to deal with garbage collection in Java. But languages coming, and right now through in scripting that we looked at today, when you look at it, if you go Google it, you'll see practically every language, there's languages on there I've never heard of that are there that it will transpile for you. And remember, if you can transpile your language to JavaScript, you're good, you can go. Sort of. Sort of. There's always a catch. All right, so, but here's what you need to remember. In the Microsoft world, they're not staying behind. You can do C# today with Blazor. Blazor is Microsoft's product for doing this. Okay? They're always like sort of out there on their own, right? I mean, they're part of us, but they're sort of separate from this whole open source, this whole, they're starting to come around. But anyway, so, and C#, right? So they've done this with Blazor. So if you want to use this technology in the Microsoft world, then that's where you want to be focusing on is Blazor. Okay, because that's their toolkit, that's their whole wrapper, that's their game to get you to WebAssembly in the Microsoft ecosystem. Okay. I ain't never heard of this language, I'm sorry. Well, let's see, Java through this open source Team VM and bytecode. Kotlin. Kotlin's a new version of Java written out of IntelliJ, meant to be more functional, more modern. And then TypeScript. TypeScript is again from Microsoft, and it's more of an abstraction on JavaScript to make JavaScript more object-oriented, not so verbose, and not so wild. And a lot of places use it because it gives a lot of control in a corporate environment for style and reusability, etc. But there's a learning curve, and you're out on your own. But you can still do this with this. Okay. So technically, it's possible to transpile a language to C and consequently compile it to WASM. So there's a couple different ways to go about this. And again, as this continues to roll out, more and more people are going to be building tools for this. Okay. What's the limitations? Okay, so one is like we talked about, flat linear memory. The garbage collection is a problem. So you won't find that happening. You can't access the DOM. Okay, that would have been a killer, right? Because if it was tied into a DOM, right, then how could you not run outside a browser? So they didn't make that mistake. And then of course older browsers, they don't have this global object. So even right now, if you have a modern browser and you're up to date, if you load a page up, you'll find this object in the DOM. Be surprised how nobody knows it's there, but it's there. And it's just like any other DOM object that you type with JavaScript. So how does EM scripting? Been around for a while, and it's really getting leverage now because of what it can do. It's a source-to-source compiler that can generate ASM.js from C, C++ source code. And you can use it to build and generate WASM modules. The encrypted role is an LLVM to JavaScript compiler, a combination of technologies that work together to build, compile, and run your ASM.js. WASM module generation with their SDK. I'll actually show you this. Okay, and this is what it will look like. C, C++, and again, don't get bummed out when you just see C++. This is the MVP. Okay? And there's really nothing wrong with C, C++ either. Okay? It stood the test of time, and in fact, C++ I think is still in the top 5 usage. So you come down, you go through your compiler, you get your bit code out, you feed it into this EMCC compiler, you get this out. You feed that into another tool called binary-in, and then that spits out the WASM. And we'll see that. So what does that mean? So the scripting uses binary-in's ASM to WASM tool to compile the ASM JavaScript output, right, to the WASM file. So the binary-in is a compiler and toolchain infrastructure library that includes the tools that you're going to need. You can go both ways, right? Which is cool. So WebAssembly has a tool. It's not the binary. You can go binary and then you can go back out to text, which is really good. But once you get back out to text, you're going to be in with the S format, so you're not going to see C. So you'll be getting tools that will now read that text and basically transpile it to another language, which is really cool too. So that means that theoretically in the future you'll be able to take, say, Haskell code in. So think about that. People will be using this, could use this tool to do nothing more than to transpile and compile languages that they don't understand. So hey, go get that Haskell library. We're going to convert it to a C++ library or a Rust library and run. Now obviously there's gotchas, right? Because nothing goes from one to one in these languages, right? Especially depending upon the programmer and what kind of constructs they use. Okay? So don't think that you can just run out there and go grab some giant like C++ package and then turn it into this immediately. You flip a coin. Okay? But they've done it. For instance, you're familiar with the package called iMagick. Been around forever. It's an open source imaging application written in C, and they've converted that to WASM, and it runs in the browser. People have taken crypto libraries written in C and done it. So it can be done. All right, so passing flags, you can control the AMCC can pipe the resultant ASM code to the binary in output to give you your WASM file. Because this, when they started with this code, this scripting, WebAssembly didn't exist. There was no concept of WebAssembly. But because of the nature of WebAssembly and what it does, this particular tool just really lit on fire by WebAssembly. Well, in summary, and it's not the end of the talk though, but just this high level here. Core specification, JavaScript API, and the Web API, these are the elements of WebAssembly. Okay? The use cases are currently supported, is what we covered. Use cases, supported tools that are enable non-supported languages, the limitations, right? The absence of the GC, the inability to communicate to the DOM, and old browsers. Right? I don't think old browsers really have much of a problem anymore. And then Inscription's role in the development process is where it fits into this workflow. So, and there'll be, this is just one out of the gate, just to get you settled. Because invariably every vendor will roll their own set of tools coming eventually. Okay? You can definitely imagine and see inside Visual Studio, right? Compiled to WASM. Okay? Inside Visual Code or IntelliJ, because IntelliJ does other languages. But the point is that you want to understand that this is going to evolve too, and it's going to get click click click. Right? In fact, it'll end up probably even being on the web where it's seamless. Blockchain usage. Now we're going into the blockchain. So that was generic, right? And that we saw that affects everything. That's the web world. So before I go into that, let's just wrap what that means. That means that people are going to be able to write applications that are going to run near native speed in a browser or on your desktop, right, through this code. So that means that there won't be an incentive anymore to really write these standalone applications, right? There really won't be a choice between, do we write a desktop server application or do we write a web application? Am I going to write it in JavaScript and Node, or am I going to write it in Java or Python, or am I going to write a .NET application for the desktop? It all blends, it's starting to blend, and it's not going to happen overnight, obviously, right? It's not going to happen overnight. But as new programmers come online, they're going to be drinking and sleeping this stuff, and that's what they're going to be wanting to write. And they're going to write the tools that they need too. So from a generic point of view, you're going to see the web starting to change in the sense that instead of writing, I already see the whole HTTP request response gone. It's archaic. It's old school. Okay? Because if you understand what you just saw, you're talking about make a request, boom, bring it down and run. And when you have a sophisticated mind with experience, and from an architectural point of view, you begin to open up new avenues of design from the application point of view. You don't have to do things the old way. especially if you're in an enterprise. Okay? For example, it's like you could start getting rid of servers, because you won't need the servers. Because it's a matter now of just loading the code on the workstations. It'll be like, you know, Johnny, who does all the builds for the company, it's to be just like automatic. When they build a machine, it's already baked in. What does that mean? What's baked in is things like databases and tables and URLs, things that are there that used to live out on a server. And remember, we're going into a decentralized environment. Now, old school running companies today, they don't get this and they ain't going to see it. But new school, when they start coming in and they got the power and they got the checkbook, they're going to realize right away, oh, wait a minute, we got what? 5,000 PCs. Each one of those PCs are you know, how often do they run? What's their idle time? 72%, boss. So they're idle. We got 10,000 PCs that are idle 72% of the time, right? Yep, that's right, boss. Okay, what does that mean? Well, the kids are already showing you called clickjacking. Well, not clickjacking, cryptojacking. You know what cryptojacking is? It's the newest thing. Forget about ransomware. Ransomware is too. If I'm a hacker, I don't want to do ransomware anymore. I'm doing cryptojacking. What does that mean? That means I'd use the same old methods to get on you and infiltrate you, but instead of encrypting all your files and extorting money from you, I want to get inside your machine and hide, and I'm going to mine. I'm going to mine. I'm running crypto algorithms and mining. And when I can go out to 10,000 machines, harness 10,000 machines and have 10,000 machines mining for me, I can make some money. Okay? So cryptojacking right now is the thing. It's in vogue. Right? And people don't even realize they're getting cryptojacked. Right? And number one is the browsers. Right? Because people, especially Chrome, people just think that willy-nilly, they load up all these plugins and that, they have no clue. They have no clue that that's an insecure, unsafe environment, that if I'm a hacker, I get in there, I can do anything I want. Why do you think Google's shutting down certain services? Because they can't control, okay? They can't cordon off, okay? And that's the environment. It's like there's no sandbox, right? There are, but it's easily defeated. Okay? So the point is that this is going to change what web applications are, okay? Because now you'll be able to write a web application that effectively becomes an MRI visual, a 3D medical visualizer, right, on the desktop or on the browser, instead of having to write an application. And it'll be served over the web, right? The whole rich streaming environment. I mean, when you have the ability to tap into the hardware of that machine and utilize all those CPU cycles, right? I mean, we're already doing real-time communications, but the kind of now we're going to be entering an era where we can literally put on our HoloLens, right? And literally, you know, if we have a field suit on and I touch, you'll feel me. I mean, it just gets crazy. And the military is at the height of this, obviously. You can imagine how important this is to the military. Okay. So, blockchain, EOS.io. We're going to look at them because they're all over. It's all about for them. The smart contract right out of the gate, okay, is WebAssembly. Whereas with Ethereum, it's an afterthought. They're working on it. It's called EWASM. So it's WASM constrained to Ethereum's needs. Okay? But it still sets up the stage for interoperability. And that right now is another area where blockchains are struggling. Okay? Because they're all islands. Right? And there's no definitive protocol. There's nothing out there that's tying them together. Okay? Because they're all doing their own thing. But what's happening is, by accident here, this WASM is coming up. And WASM gives them this capability for interoperability. Right? Because if you can get it to WASM, then you can run that smart contract. Right? So in the world of Ethereum, you can write your contract in Solidity, and they're already doing it. And then you'll compile it down to WASM. And eventually, there won't be any intermediary the way they're headed. So it'll just go right to WASM. And they do, for Ethereum 2, they do want to execute in WASM. They don't want to execute in the EVM anymore. Right? And you can understand why, because once you're in the WASM world, you open up a whole planet of opportunity for sophisticated smart contracts.
Okay. Why should one write a smart contract in Solidity when they can write it in other languages?
Well, because one is the control and it's a DSL, the concept of a DSL. So, and there's value to that, okay? Because, in other words, if you want to standardize something, right, then you want to control the vernacular. You want to control the narrative. You want to control the vocabulary. So that everyone's,
you're saying,
right?
Solidity will not go away even with WASM?
No. No. And even today, with Solidity is just, one silo, and there are other people that are writing smart contracts for Ethereum, right, in other languages. Like, obviously, Python, right? I mean, that's Buterin's favorite is Python, right? But again, it goes back to the concept of abstraction, right? And momentum. If you say, oh, I'm going to write a smart contract, well, where do I start? What is a smart contract, right? That's a problem. It's a chicken and egg, right? And then what are you going to get? You're going to get 15,000 versions, and you're going to have that problem, okay? Whereas by having a DSL like Solidity, domain-specific language, right? It focuses your mind as a developer and a designer, right? But at the same time, it's very restrictive, right? And I've always asked myself, gee, why wouldn't we want to just write JavaScript? Why not write smart contracts in Java? I mean, it's like, why wouldn't you want today? I mean, what would stop you from today creating smart contracts in Java? Well, they do. Hello, Hyperledger, right? But it's really about the design paradigm, right? And again, market capture, right? If everybody learns Solidity, right? Where do they run it? It's about attracting, holding on, making, once you learn something, the cost to take you away from it is enormous. It has to be 10x, right? And even more so if it's a pleasure to you. Okay? And that'll always be like that. So that's what's so beautiful about this, because it doesn't force anyone to change, per se. Just adapt. So ESO, Ethereum, right? And in Hyperledger, Sawtooth. Saber is their WASM vehicle. This started out as an EVM, okay, from Burrow. Burrow is another project that they joined Hyperledger and donated the EVM, their version of the EVM, right, which they open sourced it, and mainly it's about the licensing. They agreed to the right licensing. There were others they tried to get. They tried to get the C++ version, but they wouldn't give up the licensing. So they said, okay, we can't have you if you don't want to do the right licensing. So that opened up an opportunity for Burrow to come in and to pick up the slack on that end of it. So that's going out there. And again, this is Intel, Intel's blockchain. So the idea here is that, right, we'll be able to write interoperable, I'm not sure what their whole vision was initially, but obviously I see it as an interoperability play down the road because, right, that's the same technology. So it's not there yet, but I see that as the most viable mechanism and vehicle. It's like once it's mature enough, it's a no-brainer. It's a no-brainer. Okay. And then Pike, this is something brand new from Sawtooth. It's more about use case. And they were getting a lot of flack from the community because it's not really like technology per se. It's about building a supply chain. It's like, well, why are you here doing that here? It's like, we're supposed to be building tools and letting other people figure that out. But they're like, no, we're going to do that. And then it's a toolkit that people can then go and use and build supply chains. So now you can see, and they're baking WASM in here. Because this goes right back to what we're talking about with IoT and interoperability. You have shipping containers. You have refrigerators. You have operators. You have gates, right? And if all of these things can run a little micro footprint of a WASM embedded engine, right? And then a binary. Now here's the thing. Remember, we haven't talked about the factor of you go from here to here. And you go from performance here to here. Right? So the size dramatically decreases because it's binary now. And the performance dramatically increases because it's binary. So in the world of near real-time logistics, that's supply chain, right? It's all about communication, notification, right? That's perfect. So now you can have servers or desktops, laptops, mobile devices talking to a refrigerator, or a refrigerator talking to a plant foreman, a guy on a dock, and the truck's 5 miles down the road and it's talking to his phone because they're running WASM smart contracts. And they're all multi-vendor, right? But that underlying thread, that underlying fabric of communication and execution that we just saw makes all that real. Okay? No more IOTA. Change the world if you want to, use IOTA, which like Schneider, that's another blockchain, IoT blockchain. They got, I don't know, billions for the right? But their whole pitch was the world has to come and change to them. So it's like all of the industrial devices will have to be modified. All that microcode will have to be modified to run their code. Well, that wasn't going to work, right? But this has legs. Now I go to the UX. Well, it's right back to the UX because it is on the UX. So it's not only inside the smart contract server engine that has no UX, right? But at the same time, that same technology enables the UX front end, okay? And we're going to see that too. So, and right now in the blockchain world, there's no UXs. I mean, people know this, okay? If you go to conferences that are worthy and real, and they want to talk for real, it's like they all know, it's like, dude, we need UX. That whole MIS thing, that whole wallet thing, that's crazy. Mom's not going to do that. Sally's not going to do that. Okay? It's got to be that, simple. And it's got to be fun. It's got to be, immersive. Okay? You think anyone's going to like looking at a number like that? And then it says, hey, make sure you copy these 15, 12, or whatever, 12 words, because if you lose these 12 words, you won't get your money out of the bank. It's gone forever. So it's like, oh my God. I mean, just play with this stuff. It's like you intermittent, you do it one time, you save it somewhere, you come back 2 weeks later, and it's like, where the hell was that? And you go to pop it up, and Miss says, oh yeah, give me your word, give me your keys, buddy. Where are they? I don't know. It's like, we already have enough dealing with passwords, right? And now you want to stick people with keys. Not one key, but thousands of keys.
When you say UX, you're talking about one that will rule over the entire kingdom here, or just intuitive UXs for each vertical or industry product, whatever it might be?
I see this as a ubiquitous technology like TCP/IP on the internet. And that's what makes it so attractive, because nobody owns it and everybody can play to it. And you don't have to invent it. And it's like you and I, we can create synergy without either one of us having to sell each other on how to do it. It's like, oh yeah, let's hook up. Well, we do it in C. We got to do it in C. It's like, oh yeah, well my interfaces are Rust. Okay, here's my API. It's like, no. It's like the common point. So I'm going to pass on this for right now, and let's look at the real code here. I want to show you. Okay, so real quick, we're going to do this. All right, so here, terminal-wise. Well, actually, let's look at code. Oh, weird. Oops. Oh, I know what I've got. I always forget. I gotta kill that first. Okay.
Thank you very much. Appreciate it.
Hey, my pleasure. Oh. Delay. Yeah. Okay. All right. All right, here we go. Where is it? Hello, C. Okay, so here's a C program. Hello, world, right? C program. Can't get much simpler than that. And we got a little bit of dynamics, so we're going to capture our time, our local time. So that's a C program. And over here is I inscripting these tools. So I'm going to stop the server. And these tools, so you know where they're at. Find them here, right here. So on GitHub, WebAssembly, right? It's all there. And under this developer's guide, getting started, you go down, right? In my case, Mac OS X. So this is what I had to do to crank it up. Pretty easy. Well, for me, it was. And I just mean that because of my machine. So, but chances are you'll get the same bang for the buck. So that's simple. So script them. Then I'm bringing down the sample, right? So I did that, changed directory, did the install, activated. So that's what we're looking at. And here's the where I put it. Okay, Wasam. There's the MESDK, the hello. Okay. Create that app. Now, to compile it, here's the compile. EMCC, hello C, -s, Wasam equals 1. No, true. Output file, hello HTML. Give me a convenience file to run this. So, compile. And it's on my machine, and okay, that's done. And now, they provide you this tool also for development. EM run, -- no browser, port 8080, dot. And dot means it's just going to crank up from that directory and load whatever's there. So it's loaded. So you can see it's telling on my server root, and I'm listening on localhost 8080. So if I go there, find it again. Here it is. And let's run it. So what's it say? 20, 26, 35, 20, 26, 39, 42. So you can see it's running. So we have WASM, a C program, compiled down to WASM, running in my browser. Okay? Now obviously because the browser, there's no console, it's a console output, the encrypting tool. But I hope you can see and appreciate what's happening here. Okay? It's crazy.
How can you input?
Yeah. Well, let's actually now do something far more sophisticated. And over here, this is a WASM application. Okay? And the UI on this application is React and Redux. Okay? So React and Redux right now are like the de facto standard, except for some might say Angulars. But seems like 10 to 1 people do React, right, over the other. So this is a demo for EOS. Okay, so it's live. It's their game, and it's tied into the blockchain. Let's see if it'll work. Yeah. So this is answering your question. Okay. There's no. I didn't log. I guess I could log out and log back in, and that would be the input. Okay. So the idea is you build a UI, the UI, you build a field, right? You input, and what happens is in this app, right? It goes to the React code, the JavaScript code, right? That takes it from the component, but then it's going to call, in this case, the RPC API for the blockchain. Okay, and what's happening at that point is it's calling the smart contract, and the smart contract is WASM, is in WASM. So this game, I click it, and it will show you the code on it. It's coming up. So this is EOS, and they're the #1 right now on dApps. Okay, a billion plus, I think, I forget. And they just created another fund of like 300 million or whatever to try to build this out even more. But everybody that I know of is going from Ethereum to EOS. One of the main reasons is you don't have to pay anything. It's free from a developer point of view. There's no gas, right? There's no ether you got to put up. So they get it. It's like onboarding is fast, easy, and we don't make you pay. Now, obviously, somebody's going to pay, and we won't get into all that. But the point is that getting your app up and running and present it to people, and for people to come and play, like I am, is easy. Okay? So the economics now are built back inside and hidden. That's not overt to the user. So it's up to you as a designer now to figure out how you're going to infuse the economic model into your application. Right? And if you're not going to have an economic model, well, then you're going to end up paying the delegators, right? They don't call them, they're delegators, but they call them, I forget what they call them in EOS. But effectively, they're like the miners, right? So these are the people that are actually doing the blocks, taking the transactions, and for instance, in my contract, this is running on somebody's host. And there's a smart contract installed on their host. Right? Well, actually several hosts. Right? And then it's basically a random draw, right, who gets it, and who gets the opportunity to make the commitment and get the fees. Okay? We won't go, this is not about EOS and how they all work. But the idea is I want you to see here, this is an actual application that is a WASM application. And it's like, you can just see this for me, it's like, holy cow, this is it. Because what more are you going to want? The sky's the limit from here on. Okay?
Where have you written the smart contract?
This smart contract is running, deployed out on the EOS IO blockchain.
What did you write it in Solidity? No.
This game is written in.
No, not the game. I'm talking about the smart contract.
Yeah.
What did you author it in?
This one is in, I think, C. This is in C++.
Not the game. I'm talking about the
Yes.
smart contract.
The game is a smart contract.
Who's on first?
The game is a smart contract.
Okay.
You see the power here? They've blown it out. It's like, dude, it's like your question, right? Earlier. Why are we so limited to just Solidity? And just thinking about what they tell you can write and how to think a smart contract.
Okay.
In the world of EOS, a smart contract is code.
And this you have written in C.
This is written in C++. Well, I'll show you.
I think compiled in Austin.
Yes. Well, they do it all.
Yeah.
Yeah. So they have a whole tool chain, right? And a tutorial that will take you through. So they built out their, like I was saying, they have built the tool chain that masks and seamlessly takes care of that, the compile, right? That whole food chain that we saw. It's not a manual process for you. It is in a sense that they give you commands. You still have to do commands to run that you go through, right? At the command line for them, right? But it's their commands. But under the covers, this is what they're doing. Okay? Because at the end of the day, everybody's common. It's WASM. Because it's all a set of common instructions that are in a binary format that a WASM embedder can run. But how you get to that string of bytes that's common, right, is controlled by those tools that transpile, compile, validate, check, right, and then spit out that set of bytes that represent a stack array that you're going to run. Right? And then you feed that binary stream of bytes to the embedder, and the embedder is starting to decode the bytes. And he decodes them into the instructions that we saw, and then puts them on the stack. And then they get executed. Okay? And all of that is common. That's what's so powerful.
The browser doesn't have the embedder yet, right?
Huh?
Does the browser already have the...
No. Oh, the browser? Yes, the browser. Yes. Those the major browsers that we showed you, all of them now have WebAssembly built in. And that is binary code, part of the JavaScript code. Well, it's not, I mean, it's the browser code.
Okay.
But the key to this, so that allows it to expand into the whole Internet of Things, it doesn't require a browser to run.
Exactly.
That's a linchpin, I guess, that
Yeah.
opens it up.
Yeah. So you can, So you can have a kiosk running a browser that a public could walk up to, right? Say at an airport, right? Authenticate, right? And that kiosk, through their smart contract, then, remember now, the smart contract's not residing on that kiosk,
No.
right? It's out there in Neverland, right?
Yeah.
But it's sending that command out, right? Into the blockchain. And then that blockchain is now signaling the gate, right? And then it spits you out a ticket that has an RFID code, say it has an RFID on it, right? And now when you're walking through the gate recognizes you. Because it's an IoT, WASM smart contract running in there, looking at the blockchain, and it says, oh, here goes an RFID by me, got that number? And there's the gate, right? So the reader reads it, goes out, checks it, oh yeah, he's good. He checked in, he's all good, open the door, let him go. Right? And all that's on the blockchain.
Okay.
And you can see how all automated that is.
Right.
And it's on the blockchain, so it's immutable. You can't defeat it. Now, if your protocol is fucked up, right?
Right. Yeah.
You're screwed.
Yeah.
And the protocol meaning could be, is really more about the human process, right? If somebody leaves the door open, right? I mean, it's the old thing, like, just wait here long enough till somebody goes through and then follow. Well, I mean, come on, right? So these are called side channel attacks. So you gotta watch for the side channel attacks, right? But you get the point, right? And this is like, so here's the game. So it's like I could be playing this game and earning tokens and earning money. This game could be a shopping game where I'm evaluating products for a customer. This game could be where all I'm doing is identifying objects, and I'm getting rewarded from Google because I'm allowing them, I'm helping to train their AI.
Well, what about, speaking of games, what if I'm playing on PlayStation and someone else is playing on Xbox? Now, can we play together now?
Yeah.
You see what I'm saying?
Yeah.
We have two disparate operating systems within our gaming systems. But
Yes, absolutely. Why? Because the blockchain is common state.
And now does that open up those games to, basically the crowd to build just a generic web, WASM application that can be used on both games?
Yes. Yeah. So you could have a WASM app that's a retail marketing type of loyalty app, right? That you could create assets, right? Say a gas pump that has your logo, right? And that gas pump can literally now be dropped in to each one of these disparate gaming environments.
Excellent, yeah.
And rewarded because if whatever, right? You go to the gas pump and you use it and you're a customer in one game, you're rewarded. You're over in another game, you're rewarded. And that has far-reaching effects from the ubiquitousness of the transparency of our life as we move around, right? Because think about it like change jobs. What a nightmare, right?
Yeah, exactly, yeah.
So it eliminates that type of problem too. Think about HR, what it does for things like HR, right? Think about banking in the sense of accounts and authentication and the whole supply chain from, you go to the driver's license to get your driver's license. So it's like now once you've done that application on the blockchain, right? Now when you go to open up a bank account, yeah, they don't even have to ask you for ID. All they do is look at you. What's your name? It's like, and they won't even probably do that because it's like they're hooked up. So it's like it recognizes your face and you pop up. Oh yeah, hi Mr. Morris. It's like boom, yeah, you're set. You're all good to go.
Because they're part of the
now this is good and bad, obviously.
Sure, yeah, I get it.
Right? I mean, everything's a two-edged sword, right? Everything's a two-edged sword, but you have to manage it. But the benefit and when you think about cost, really, right? I mean, you're talking trillions and trillions, and don't let Ocasio hear this, because she'll like suck that. She'll say, "Oh my God, that's where the cost will come. That's where we'll get the money from." It's like, and in a lot of ways, I mean, if you think about it, if you apply this technology and blockchain in a ubiquitous manner into our systems, think about the cost that's waste, right? It's just friction that burns off, right? And it's not anything anyone does, right? It's just part of interfacing.
Right.
It's just part of interfacing. There's a cost factor to interface, and this eliminates all of that.
Well, it's kind of interesting reading about Estonia and how they're, kind of turning into opening up a digital citizenship type setup.
This is their blockchain. I'm hitting the button down here, get info, and you can see the numbers updating. See the head block? What's this up here? Head block count. Head block count. You won't see that on any other blockchain. It's sub-second. Okay? So it's meant for throughput. Right. And it'll scale linearly with more
Latency
with
issues.
more nodes. Right. The way the model's set up. Right. Yeah. So you want to see that code? Let me show you that code. So they're on. Yeah, here we go. So here's the game. So you see here, okay, so front end, look at that real quick, just open that up. Oh, maybe I should, okay, yeah. React. So if you're a JavaScript guy, Node guy, this should look very familiar to you. So that's the front end, React. But looky here. That's your interface. That contains the methods that you call to the blockchain.
But the actual game is written in React.
I'm going to show you the game written in. Here's the card game. See contracts, card game, C++, card game. Okay, so code, header, code. So what's the card game code? C++. So unless you're a C++ programmer, I am, or was, and I will be, and I am. It might be scary to you, but it's really not. So you can see card game, namespace, right, login, there's your login, the method that gets called on a smart contract, passing in the variable. Username, users, that's a table. Users is one of those tables, an indexed table, right? And the index, it's indexed on username. So it says find, right? So it goes to try to find a user, right? It finds a user, then it sets its name. Then you're logged in. Start the game, right? Require. All these have, in this case, right? Require authorization. So they handle that for you right there. You don't have to deal with that yourself. Right? Boom. You're not going to get past. Okay? Unless you're authorized. And then again, users, the name. And now we're going to modify state. Okay? Game data. Make a new game. These are C++ classes. So this is all just regular old C++. There's nothing hairy going on.
I'm sorry, Mark. I'm having trouble understanding. You have C++ code, and you have React code, and you have smart contract. And then you have the front end.
Well, the front end is the React.
Front end, the entire game front end is React.
The game is built into, the concept of the game is built into two pieces.
Okay.
The smart contract, which handles the state.
Of the game. Okay.
And then the UI,
Okay.
which is React.
Okay.
So React captures the input
Okay.
and renders
All
output.
interaction is captured with the React. It passes on to the backend, which stores the state, and then,
Right. But what you pointed out was that, which I didn't really think about. Yeah, the smart contract. To me, I didn't even think about it, but how different it would be. But you're right. It's like, because most people today think of smart contract as how Solidity defines it. It's like a contract, in the terms of a contract. Right? But the reality is, even in Ethereum, it's not. It's just state management. It's just state. It's state and state management, okay? And you pay for the state. When you want to change it or write it, you pay. But you can read it for free. Okay? But in Ethereum's world, state costs money. And instructions cost money. And gas. In this game, in this world, that's not, no, you don't. Which is so critical, because when I write a contract in Ethereum, the very first thing I have to think about in my mind is gas conservation. Okay? I could just, go write a freaking contract and not worry about it, right? But I mean, who's going to use it? You got to buy them, it costs a Mercedes to run, right? So, and that's a game. You have to play, and you don't want to play that game because that cuts down on the functionality that you want to do, right? So in my world, I have come to, well, if I'm going to do Ethereum, what I do is I use Ethereum strictly as a minimal state engine. And if I can if I can wrap up all my state into a bit map, where each bit represents something, maybe a row, a person, some state, right? And then there's ways that you can create these bitmaps today that are very rich, like a database, but they're extremely compact because it's just a bitmap. Okay, so that's the way I'm thinking there, because all I want to do, all you need in the world of Ethereum is the state. You got to write the state, but you don't want to put anything else out there because it costs you an arm and a leg. And oh my God, you're not going to put storage. That's forget it. Nobody uses the storage, right? Because it just kills you there. So there's a lot of problems. But when you look at this system,
which is EOSIO, or is this?
No, Ethereum.
No, I'm talking this system.
This system, yeah, I don't think about that at all.
So what is this? Is this WebAssembly, or is this the EOSIO?
This EOSIO is the company, and the blockchain,
You're right. Okay.
right? And their implementation, their design is incorporated WebAssembly as the smart contract mechanism.
Then how do they make their money? How do they, how's it become self-propagating? How do they?
Yeah, I haven't figured that out yet.
Yeah. Okay. All right. Yeah.
I'll be honest, I haven't figured it out. I'm still trying to figure that one out.
It's a utility that, it's just a public good.
No, there's
Media.
there's a cost. There's a cost that you have to. Obviously, you have to pay the miners. Well, first of all, so here's how there's a couple things going on here. I could do a whole presentation on at the heart. If you want to understand EOSI, you need to understand and read their white paper and read Multicoin Capital. Read their analysis paper on the delegated proof of stake. Okay, and because it does a really good job of breaking it down from not so much of a technical, but from a economics point of view. From like someone who has like a master's or PhD in finance and economics, no, I'm serious.
That's not me. That's why I'm laughing. I'm not saying.
And that's how they're analyzing it.
Yeah.
Okay, the pros and cons and all that.
Sure.
So part of the problem, so one of the ways that you get around it is there's only a few ways you can make money, and so it seems like what they've chosen is inflation. Okay, so miners, when they do good work and they commit, they get a reward. They get blocks, or not blocks. They get tokens. Right. So and tokens, the economic model is set up so that I think there's like a 4, 5, 6, 7, I don't know what it is, % inflation yearly, right? So if you hold your token and it's $1, next year it's going to be $1.07, right? So you're earning 7% on everything. You get it now, right?
Yeah, you just got it. It's more
you get
bond than stock.
Yeah.
As far as that.
And then I haven't got in deep enough yet. I got that far on it, on what it means to me. On what I need to do, what I need to know as a developer. Right now, I'm just focused on the technology because I want to crank some things out. And in the long run, it's like I'm not that concerned because I'm doing my own thing, right? So I basically am taking their delegated, what they call delegated proof of stake, and I've created a new model, a new one that addresses a lot of things in that paper. Okay, and I can tell you that, and mine's, I'm not sure what the exact name, but so far it's coined, I guess you could say. Actually, I had franchise proof of franchise proof of stake, but then I realized, it's more like it's just going to be proof of franchise. So I have a concept of a franchise, right? So I'm going more towards normalization, right? Instead of anarchy and the whole concept of trying to create a whole new system of economic feasance, which I don't think can exist. Right? I mean, it can't, because humans don't interact like that. Okay. But I look around. I look at what's successful today in the world of business from a scale. And so I'm saying to myself, well, fuck, man, franchises. Okay? So at the end of the day, like I was telling my friend, there's already chatter among very influential people who are now coming in from finance, IT, executive, very smart people who give a shit less about the technology.
Right, they're trying to see how you...
They're smart. They're the smart ones. Okay, we're the dumb kids that build the stuff with the propeller hats. Right? And it's like, hey, look what I got. Look what we got. Let's go sell it. It's like, bring the customers in so I can show it to them. And they're like, dude, calm down, time out. It's like, no, you don't understand. If our customers see that, they're going to run for the hills. Okay? As soon as you open up your mouth and you show them that number, they're going to sleep. What we need to do is put that puppy behind the curtain, okay, out of the way, and get something pretty to look at. That's where we're at today. And those are the people now that are beginning to come in and take the reins. Okay, now obviously the kids don't want to give it up, right? They still want to. But at the end of the day, these guys are going to win. Right? So I'm on that side of the camp. I've just been too damn cautious. Okay, I've been too much trying to be like the boys, the little kids, right? Instead of just looking at reality, right? And so I have technology that I've been working on that's stealth. So it's a whole networking technology. It's a layer 3 technology in the technical stack, right? So like IP is layer 3. So you have physical, right? Which would be either like wires or air, right? Then you have layer 2, which is the data layer. So that's where the signals get converted to numbers. But they're not, they're just a string at that point, in frames. They're in frames, right? And then they pop up to layer 3, where layer 3 IP parses out the frames to give us addresses and content. Right? So then that's how the internet runs, is on layer 3. Because that's where all the IP addresses are, that's right. So now that's how everything runs around. And then once you get to IP layer 3, and you resolve layer 3 to a node, to what they call a MAC address, which is a physical device, which pairs up, right, in a subnet. Now it goes up the stack to layer 4, 5, 6, 7 to the 7 is the app. Right? And then I type this down, and it goes all the way back down, all the way back out now. So what I'm doing is I'm inventing a layer 3 technology called BIP, Blockchain Internet Protocol. So it's a completely different protocol, right? And the beautiful thing is that all the IP traffic won't be able to see it. So all of the tools out there won't see it. They can't ping it, they can't find it. Okay? Now think about a network of autonomous hidden nodes that are collaborating, but nobody knows who you are. You can't collude.
So, yeah.
Okay? So, if you want to hook up with me,
Well, I'd like to chat
I'm
with
looking.
you.
I'm looking for, able-bodied partners.
Well, I'm definitely in it. My area of expertise is in aerospace defense. And intelligence surveillance and reconnaissance for the Department of Defense. And so their big thing is they want an open architecture system where they can run, it's truly open architecture. It's I don't know how to put it. I guess it's Linux. It's not Apple.
No, this is, yeah.
Right, and that's why I was looking at the web system, is because they want to be able to be in a situation where they can go out and crowdsource a functionality of a particular sensor, a
Yeah.
capability mode, right?
Yeah.
But they don't, and they want that to be able to run on that, basically, on any hardware agnostic of who the vendor or supplier is, right?
Absolutely.
And so that's, that's kind of it sounds like WebEx is something that could allow. And then on top of that, they want to say if there's an update to that particular thing, they want it to be a trusted and ubiquitous update throughout all the sensor network. That, so it can't be hacked or,
Yeah.
they have to, and it can't be, and of course they have to deal with not only cyber attacks, they have to deal with electromagnetic
Oh, yeah.
warfare,
Yeah, there's a lot going
all kinds
on.
of other different vectors, not just from wires, they come
No, I
from
know.
sensors. So that's the big thing. But yeah, I definitely like to get with you. Maybe, I don't know if I can swim or use my card.
Yeah.
And it'd be great to sit down. I'd love to take out to lunch and sit down and chat for a while.
Yeah, definitely.
So kind of start seeing, what's up.
Yeah, let's do it,
Possible, yeah.
get a little POC going.
Well, yeah, that's what I'm thinking here, is that, there's all kinds of opportunities out there. There's that aspect of, how do you missionize the capability? And I was talking
Satish.
I was talking to Satish. The other side of our real deficit in our process is our acquisition process. It takes 5 years to execute an acquisition, whereas our peer competitors, anywhere from 2 months to 6 months to execute the same technology spin, because they're not burdened by that acquisition, or they're not encumbered by that acquisition
Yeah.
process.
But is that a constraint of a political system or a regulatory system, or is it a?
The regulatory system, your federal acquisition regulations and oversight and all that.
So technology wouldn't help that, right?
Well, potentially, right, because those are all.
Oh, whoa, no, let me
they're
stop.
run by
No, it
people,
would.
right?
If it's regulation,
Right, and
then
algorithm.
that means things like compliance.